This meeting is being brought to you by the Fractal SUS Edge. All right, we go on. 9.6 will be about logarithm laws. 9.7 is about log and exponential equations. Okay, in a certain sense, the laws of logarithms are the opposite of the laws of exponents. So, I mean, b to the 0 is 1, log base b of 1 is 0. B to the 1 is b, log base b of b is 1. This and this are saying that logarithm base b and exponential base b are inverses. Here, exponential of a sum is a product. Well, logarithm of a product is a sum of logarithms. Logarithm of a so exponential of a difference is a quotient. Logarithm of a quotient is a difference of logarithms. And similarly, log base b of x to the p is p log base b of x. Basically, x to the p is repeated multiplication, and logarithm turns times into plus. So log of a power turns into repeated addition, which is p times the logarithm. Now this one, it's related to this one, change of base formula. Given that your calculator will have log base e and log base 10, but not other bases, this gives you log base any other base of x as a ratio of logarithms. Log base a of x over log base a of b, common log of x over common log of b, natural log base e of x over natural log base e of b. So there's all that. Okay. So, just before I go on, there's a pH scale. pH is minus the natural log of the hydrogen ion concentration in a solution. That's what this bracket expression is. But it's not actually a hydrogen ion. A hydrogen ion is a proton, a subatomic particle. That doesn't really hang out in water too well. What happens is it attaches itself to a water molecule and thus becomes an H3O plus ion, known as hydronium. So okay, so whatever. The pH is minus a logarithm of the hydronium ion concentration. It's in neutral water. It's about 7, 10 to the negative 7th is the concentration of hydronium ion in a solution. Who just walked in? Jane Kim. Okay, fine. As the 10 to the negative 1, that's very, very acidic, which makes it sour. Acidic is sour, base is bitter. That's why they serve you lemon with fish, because fish, you know, they taste of the sea, and the sea is bitter and basic. So they give you a sour lemon to neutralize it. So that's how that works. 9.6.2, 9.6.3. Okay, so here we have some problems. Simplify a common log of 7c over 2. Well, logarithm of a ratio is a difference, log 7c minus log 2. This is a product, so it breaks into log 7 plus log c minus log 2. Here we have common log of x to the third y to the second. Well, it turns into a sum of log x to the third plus log y to the second. And the power of 3 comes out in front, and the power of 2 comes out in front. So you get 3 log x plus 2 log y. Now, this is a little bit more complicated. Log base a of the cube root of x over the fourth root of yz. Okay, it's a logarithm of a ratio, therefore it's a difference of logarithms. Log base a of cube root of x minus log base a of fourth root of yz. Now, the cube root is a 1/3 power. A fourth root is 1/4 power. These 1/3 and 1/4 come out in front. 1/3 log base a of x minus 1/4 log base a of yz. Now watch out. Let's be a little bit careful here, because people often come to grief here. This log of a product is a sum of logarithms, but make sure we keep this inside parentheses, because we have a minus here. If I wrote minus a fourth log y plus log base a of z without parentheses, already you're wrong. Somehow, basically, the z will have gone from the denominator to the numerator. No good. So it's log y plus log z in a parenthesis times minus 1/4. Then you distribute -1/4 and you get 1/3 log base a of x minus 1/4 log base a of y minus 1/4 log base a of z. Here we have log base 5 of 1 over t cubed to the d power. Well, out comes a d, so it's d log base 5 of t to the third. A reciprocal of a third power is a negative third power, d log base 5 of t to the negative 3. Negative 3 comes outside and you get negative 3d log base 5 of t. Here we're going in the opposite direction. We have this expression in logarithms. We're going to write it as a single logarithm. -3 log base e of x minus 2 log base b of y plus a half log base b of z. We'll bring the 3, the 2, or let's say the negative 3, the negative 2, and the 1/2 inside the logarithm. So it'll be log base b of x to the negative third plus log base b of x to the negative 2 plus log base b of z to the half. And then sums turn into a product inside the logarithm. Log base b of x to the negative third, y to the negative 2, z to the half. Then negative 3 and negative 2 power are a cube and a square in the denominator. A half power is a square root. So you get log base b of the square root of z, that divided by x cubed y squared. Estimate to set 4 places. Log base 3 of 7. Well, by the change of base formula, this equals a ratio of, let's say, common logs. It's as good as any. So we common log of 7 divided by common log of 3. That's these, and a little bit of calculating, you get 1.7712, approximately. Log base 3 of 8, similarly, is log 8 over log 3. So 0.903089 over 0.477121 approximately, and that to 4 places is 1.8928, about, plus or minus. But who knows what's afterwards, and this may be a plus or minus 1, and this might be a plus or minus 1. Which of these are equal? This should be written 11 to the 4th power. It looks too much like 114, my apologies. It's 11 to the 4th power. You have 4 log base 211, and here's the 4th power of log base 211. This is not equal to the others. This equals that because the 4 comes out. There that is. So A and B are equal, and not neither to C. What is the pH of a solution with a hydrogen ion concentration of 1.7 times 10 to the negative 5th? Well, it's minus logarithm of 1.7 times 10 to the negative 5th. Calculate out a bit, 4.77. Oh, by the way, reason why a negative is otherwise, that's the way you don't have to have a negative attached to every logarithm. Every pH, that is. Okay. That concludes this part. Stop recording for now.